Thank you everyone for joining me today and welcome to this session. My name is Nelly Sattari and I'm going to talk about serverless real-time applications today. But before that, I would like to make sure that we are all on the same page in regards to real-time features. So let me share one of my experiences with you. So I actually work at in City, number 5 Martin Place building, where we have a very luxury reception. And every week we actually buy a big, beautiful, expensive flower bouquet for the reception. At the end of the week, we are not going to throw it out, and then we put in a bid for the flower bouquet. The problem is, whenever I participate, I actually win the competition. Everyone thinks I'm either so lucky, which I don't deny, or I place a much higher bid than other people, which is not really true, because I normally just win by, like a few cents differences. The thing is, when I pop into the website, I realized that there is no real-time feature in our website. So 2 minutes to the closing time, I pop into the website and I take a very high technical solution, which is this. So I just keep pressing F5 and get the most recent context, and I could see what other people place as a bid. So I could just add a few cents and then submit my request, and I win. So I know that it's not really, I acknowledge it is not really a fair solution. That's why I came up with a POC for my company to show them how easily actually we can build a real-time functionality and then add transparency to the application. So I created this application, deployed to the Azure, and you can see 2 people can open the browser. You put your name, and other people are informed about the other visitors. And whatever you put as you place as a bid, everyone immediately, without any delay, can see. It means that you provide enough transparency for everyone, and it's fair, and people with less knowledge wouldn't lose, which is not fair, and you include basically everyone. Real-time applications are not the one that client pull the content periodically. Real-time is the one that push the data when data is available. Probably the websites with high frequency updates are the best candidates, including any social apps. You know how pleasant it is to get the notification quickly, or online dating. Nobody will date with someone who is not responsive, so you need to get the context quickly, then you can reply. Tracking apps, you can track your Uber ride, you're tracking your shipping package, or sometimes your kids in the school car. A different variety of online gamings where you will lose the game if you have even 1 second delay. The last but not the least, any kind of dashboard, like security dashboard, incident dashboard, or flight dashboards, which are designed based on event-driven architecture, basically. So if you wonder how we can add real-time functionality to our application, maybe this is one of the things, Azure SignalR Service is one of the things that you would like to have a look. In general, we use SignalR to build our real-time applications. SignalR is an open source library which basically simplified building real-time applications. And it is shipped with ASP and ASP.NET Core later on, so you need to know ASP.NET to write, which I'll explain later. 2 main features, thanks to Daniel, I don't need to explain more. 2 main features for real-time applications. One is persistent connections between clients and server. This is the mandatory feature, which probably people can use. SignalR can use WebSocket or any other methods under the hood. And then bi-directional communication, where client can make a call to the server and server can make a call to the client as well. In the traditional real-time applications, we have lots of challenges, especially when your website is hammered by countless number of clients. So you have to manage lots of things. One of the problems I can emphasize is the persistent connections. Although this is one of the required features for these real-time applications, it's actually problematic as well. The reason is persistent connections consume lots of resources from the server. And it's not like the normal HTTP request and response that clients going away. No, they are sticking to the server because they are based on the persistent connections. So it means that your server will be overloaded much quicker than normal applications. And the server at some stage will reach the maximum capability in terms of CPU and memory, and it will fall over and overload it. As a rule of thumb, normally we do the scaling for our applications, which is fine. However, in our scenario, it wouldn't work because once you have the collaborative clients, they want to send the messages to the other clients and talk to other clients. That would be problematic. So let's say one of the clients wants to send the message to all other clients. The server will take the message and will broadcast it to all connected clients. So far, so good. But what about the other servers and other clients? They wouldn't get the message because they have no idea about each other. So that's the main problem. The traditional solution is implementing your own scaling approaches, which is really complex and overhead for developers because you have to use Redis cache, SQL as a backplane, and then you propagate the connections information between servers and doing lots of things, make sure it's available, you monitor everything. So it's not really a proper choice to take. That's why we are looking at Azure SignalR Service, which is basically it adds the simplicity to your application when you want to use it in the high load and high traffic. Azure SignalR works as a proxy. It means all the persistent connections are delegated into the Azure SignalR from now on. So it means that the app server wouldn't accept any persistent connection anymore, and all the persistent connections will be redirected. Given this diagram, the client will negotiate to the server, but instead of staying connected, it actually gets back the URL of Azure SignalR. And then they both stay connected to the service. So basically, it's a proxy in between. Since the service sits between client and server, the data channel is established from the client to the server, and the message will basically go through the service and then will be broadcasted to servers, and the server already know who are the connected clients. So they will broadcast the messages to all clients. The problem is solved. Azure SignalR Service is a fully managed service, which means you don't need to be worried about logging, monitoring, scaling, or whatever else. So everything is out of the box. There are some interesting facts, probably out of the scope, about the pricing and other things, which I'm happy to chat after the session. If you want to set up the service, it's really easy. You just need to create and deploy your service through one single line. So this is the Azure CLI line command, and then you just run this or use the ARM template instead, and then you will spin up the service. That easy. To confirm it, just pop into your portal, Azure portal, and find your SignalR recently created one, and you can look at all the features, including the logs, and everything. Like you can get the connection string from the service in order to connect. So getting back, having a flashback to my application, I used Azure SignalR Service, I used ASP.NET Core, and I used Vue.js for the client side. You need to have like ASP.NET Core, as I told you, in order to take the connections and managing the broadcast, messaging, and everything. So this is the code. This is the ASP.NET code. So you need to inject the SignalR to your application, make sure it uses Azure SignalR, and you pass the connection string to the service. Then you create a route, so the client can make a call to this route and then fall into this class, the hop class. So all the methods in the hop class are available for the clients to invoke. It means that they can make a call, and then the server also is able to make a call to all the clients, or maybe one client, or a group of clients, whatever. So when the message comes from the client to this class, it will be broadcasted to everyone. Everything sounds good. Azure SignalR resolved all the problems, the scaling problems and things. However, we still have a few more issues. One of the things which is probably obvious to you is SignalR is an amazing library, but it's tightly coupled into ASP.NET. So what if I'm not a developer, like backend developer, or I'm not using the ASP.NET stack? Or you could see from my code that the design is quite monolithic. So everything was in the big chunk of ASP.NET Core, including your connections, your broadcasting, or even in the real life, if you have any database operations, you have to manage them as well. So it's not really a best practice. Going serverless with help of Azure SignalR Service give us this opportunity to break down our monolithic code into some event-driven APIs. So we can move towards microservices. And I don't need to be a .NET developer. Why I should be? I can be a JavaScript developer, or I can, like using Azure Functions, using my language of choice, Python, Java, JavaScript, or whatever, and write my code. In order to switch to serverless, it's really easy. A few steps I show you. One is just find the SignalR service that we just built and deployed, and find the setting, and just change the mode to serverless. That's it. You don't need to do anything else in the Azure side. The next thing is you need to create your functions, because we are not going to have ASP.NET application anymore. We need some functions. We have one required functions, but probably we have another essential one as well. So the function which is negotiate is the one that client invoke, like make a call to that, and then get back the URL of Azure SignalR Service. And then after that, stay connected persistently. The second function is probably you need to broadcast some messages due to some event happening into your area. So you have some messages you want to broadcast. This message will come through the service again as a channel, and then will go and reach the clients. Just make sure this point that when with ASP.NET application, I show you that the server and client both have persistent connections, right? But with this one, we don't. And the reason is obvious, and it's fair enough, because Azure function spin up, run the code, execute the code, and then will go away. This is how the serverless works, right? So there is no basically server that we can connect. So this makes me think of clients as a listen-only mode, because there is no server they can send the messages persistently to. Which is fair enough, it's fine, because you take care of lots of other opportunities. You actually don't need to host your server like persistently and permanently. It is not a VM, which is running all the time, so you pay as you go, and all these benefits, but you have some restrictions as well. Just make sure that you choose your scenarios carefully. That's my message. I was thinking of a proper solution and scenario, how I can build a demo and show you. And I was thinking of this flight center application. So basically all over the world, whenever a flight is landed, the connected clients can be broadcasted and will get informed. That sounds like a proper scenario for broadcasting messages and using serverless. And I show you how I built it, how we combine Azure SignalR with Azure Functions and these sort of things. Azure Functions, honestly, offer a very productive programming model, which I really like it as a developer. They offer triggers and bindings. The trigger is what makes a function to be invoked. And the binding is how one function talks to the other functions in terms of, like passing a data to the other functions or maybe receiving data. So with Azure Functions, we can leverage Azure SignalR output binding and then broadcast messages to everyone. Having our example, the flight center, let's say there is a third-party API which, when any flight is landed, it actually populates the flights into the queue. And then the queue can be basically a trigger. So it can trigger the function, the broadcast function, and will pass the flight message to the function. And the function can use the output binding to basically pass the message function to the SignalR output. And then out of the box, SignalR knows how to broadcast messages to the persistently connected client. The amazing part is you don't need to write lots of code, opening the SDKs and writing lots of hard code. You just pop into your portal, or you can do it through the code. Select your function and just tell it what is your trigger, what is your output binding. So the output binding is the SignalR and the trigger is the queue. That easy. Given the code, this is basically the only code I have to write. So the queue triggered this function. This is the broadcast function. And pass the queue flight, which has basically the flight, into the function. Then you need to create a new object based on SignalR requirements, which has the actual flight and it has the client-side event, which is listening to the function, the name of the event. So you create this new object and then you pass it to the Azure output binding. That's what you need to do. Seriously, it's nothing more that I hide from you. It's all what I took. And I provided all the codes and 2 blogs in regards to real-time functionality and applications and whatever you need to know and how to move to serverless. So look at my website. It has all the links and references as well. Thank you, everyone.